to ground before he was supposed to present. That's Andreas Stamatillo, the CEO of Europe and Nation E, but he will join us another time. However, today we have Bertrand Deprez, Head of European Affairs for Schneider Electric. He will present on demand response at the core of resourceful energy systems. We are also very happy to have Jukka-Pekka Häkli, CEO of Steam Sustainable Energy Assets Management, based out of Finland, and they have some very interesting programs that they're working on with commercial customers there. He will be telling us about that. And we have the pleasure to also have with us Scott Petersen, Business Development Director for Smart Grid Solutions Europe and North Africa for Honeywell Building Solutions. And Scott has very hands-on, a global perspective on what's happening and how these types of programs are developing around Europe, but then also, of course, everywhere else as well. And he will be talking about enrolling commercial customers in demand response programs without financial incentives, experiences from the UK. So we're really looking forward to hearing you all. Thank you very much for joining. I would like to add, please write in any questions you have anytime you'd like throughout. And at the end of the session, we will have a half-hour question and answer period where you will be able to ask questions of these experts. So thank you very much, and Marcelo, back to you.
Thank you very much, Jessica. Let me see here. Okay, thank you very much, Jessica. I would like also to make sure that you include the name of the person that you would like to get the answer from in your question. So let's not lose time and let's start with our first speaker, Bertrand Deprez, who is head of the European Affairs at Schneider Electric, and will present us the topic demand response at the core of resourceful energy systems. Bertrand.
Right. Can you hear me?
Yes, we can hear you.
Okay, perfect. So thank you, Jessica. Thank you. Thanks to all of you. Just a small correction. I'm not head, but director. So it's just a small amendment to my title. Thank you for giving giving to Schneider Electric the opportunity to speak today. It's a very timely and important topic for us. As some of you know, as many of you know, I hope Schneider Electric is a leading energy management company, and a large part of the business we do is dedicated to demand side management, including demand response for tertiary buildings. We are also the owner of the biggest energy aggregator in France today. So what is interesting about this webinar is that it shows demand response with an angle not so much discussed in Europe so far, which is the importance of demand response in connecting its end-use energy resources in building to the energy network. So it's worth to see how this mechanism could be highlighted in the context of the current debate about the climate energy package at EU level. But first, demand response. I mean, many of you know that it's a fast-growing market everywhere, especially in the US and Europe, and that basically it is a very cost-effective way to address shortage of supply for a limited period of time and to address changing energy paradigm happening in many parts of the world. So you could see on the screen the huge increase of demand response side, which in Europe, which should happen until 2020. Now, looking at what I would say is the basic about demand response, you could see on the screen the three types of services that demand response could bring into the energy system. Firstly, it has been conceived to reinforce the security of energy supply by providing demand-side response to energy peak. Secondly, and I would say especially in Europe, it is becoming a critical resource to balance the integration of intermittent renewable energy sources. And thirdly, it makes demand-side sources eligible for remuneration mechanism in energy markets. But I think demand response is not only a new service offered to customers and to grid operator in order to ensure the system reliability. Demand response is a game changer that set a market value to a much larger of energy sources than any time before. And if we look at the whole energy system, as you could see on the slides, demand response can help to aggregate a large range of demand-side resources that now could be distributed, for example, into a virtual power plant. Demand response is at the core of a new integrated energy system which involves new and old market players and could be put in place quite easily in places like tertiary buildings thanks to technologies like automation and control systems, for example. That is, however, not the case in many countries today due to the number of regulatory barriers in place. Now, coming back to the main topic of today, and I think what is interesting is that the fact to look at the integrated energy system leads us to have an in-depth view at the macro level. And the macro level is the end-use energy, and it's mainly building in Europe with 40% energy consumption. And it's where demand response plays a key role because it's a driver to level up the efficient and the flexible energy consumption which happened in tertiary buildings into the energy network. You could see on the screen different layers that could transform a typical building into a smart building. What you see is a kind of maximalist vision, since strategies and technologies might be very different from one building to another. The layers and the technologies are not all indispensable. That depends very much on rationale like the building time and the ecosystem which is around it. However, in most of the cases, demand response is a powerful means to aggregate distributed energy resources and loads that could be traded in energy markets and give an additional incentive to connect the building into the grid. So what is important to remember here is that demand response is a critical step in any strategy which aims to translate flexibility in consumption of an asset like a building into a market value. And that the investment into energy efficient technologies such as energy monitoring, a building management system, or even like thermal insulation could greatly facilitate the deployment of demand response programs, because it could help to monitor what is going on, to put in place processes, especially control processes, which are very often key to have demand response program in place in tertiary buildings. And it can also help to smooth the program deployment. So in the end of the day, it is a combination of flexibility, efficiency, and demand response which has a real potential, but which needs further work from all stakeholders, from policymakers to the policy community. Now, last but not least, I want to show you an example of a collaborative project which has been developed in France and in which we are involved. This project was for 10,000 employees business district in Issy-les-Moulineaux, just outside of Paris. The objective of this project was to interconnect buildings totaling some 160 square meters of space in order to optimize the business district energy consumption and demonstrate the full range of technologies available for today's urban eco-neighborhoods. 5 tertiary buildings were retrofitted or equipped with new on-site systems. Building management system software was configured, as well as local systems to manage local production and curtailment capabilities. Interfaces were set up with the smart grids, and demand management analytics were implemented to enable connection to upstream systems. So the business, after 2 years of experience, the business district was able to reduce energy-related costs by accessing demand response program and maximize the return on renewable energy investment with 100% locally produced electricity. Many projects like this one are under development. To conclude, I would say that the current energy and decarbonization agenda at EU level provides a real opportunity to combine benefits offered by the different worlds: the smart world, the efficiency world, and the flexibility world. And that demand response is very often at the center of it. So let's make sure that we make the best of it. Thank you.
Thank you very much, Bertrand, for your interesting presentation. And now I would like to pass the microphone to Jukka-Pekka Häkli, who is CEO of SEAM, Sustainable Energy Assets Management, and who will present the challenges in utilizing demand response in buildings in Nord Pool and it's the Nord Pool market environment. Jukka-Pekka, you have the microphone.
Thank you, and I thank you also for this opportunity to speak here. So I'll go quickly to my presentation. First, something about our company. Basically, we are very different from Schneider. We are a startup which was founded in 2011. Our business idea is to make demand response tradable commodity. So basically, we combine automation systems and knowledge of the energy market to bring demand response primarily to the market environment. We are a subsidiary of Syncron-Tech, which is the leading provider of the energy management systems in Finland. So that gives us a good background, sort of technical-wise. The driver for demand response also in Nordic environment comes from quickly increasing amount of wind power and also other, but it's mainly wind power. We don't have that much solar yet here in Nordic countries. So basically the driver is wind power, and because of current forecast methods for wind power are not suitable for the trading environment that we have here in Nordic. But basically because the main market here is the day-ahead market, and wind power is basically you know how much wind you will be get only when we come to the intraday market. So that's the reason why there is now a trading opportunity if you have flexibility in your consumption. And also other market for demand response here in Nordic is the frequency reserves, which is basically a TSO market. So traditionally the hydropower has been sort of the main source for this market, but now there's no that much new build hydro at the moment, so the demand side has to start participating also to this market. And this is probably the market where the premium for demand response is increasing most rapidly at the moment. So this is very suitable, especially for buildings. Here we see how the Nordic market is basically built. So there are different classes of demand response which can be fitted to different sort of markets. So basically some of the demand response measures require a lot more planning than the others. So that also the sort of time frame of the market regulates what sort of demand response can be traded in different markets. Here you can see Fingrid's classification of different marketplaces for demand response. So if we talk about the buildings, basically, at least here in Finland, the consumption and especially the flexibility in buildings is so small that there are only some of these marketplaces available for demand response for buildings. It's basically those 0.1 megawatt minimum limit marketplaces which are suitable for building. What did I do now? Building demand response from buildings. And also one of the problems is that according to the market rules here in Nordic area, the flexibility has to come from one open delivery chain. That basically means that the aggregated volume that you are trading in this market has to come from basically from one client, or the electricity seller for that client has to be the same. So you can only aggregate buildings which are sort of which buy the electricity from one buyer. This is because of the balancing issues. So this is one hurdle for aggregating a lot of buildings into one volume. And that's also the main sources for, based on our experience. We have a couple of pilot projects where we are working with. Of course, Finland, it's mainly heating and cooling, which are the main consumption components. But majority of the buildings, especially commercial buildings, are district heated. So the sort of potential there is not that great as you might think from first. The heat pumps and cooling compressors are probably the best ones because they run pretty much all the time, and they can be used for this frequency controlled market quite easily. Also, because we have very strict building codes here in Nordic, the buildings can store heat and cold very well. So long pauses in this heating and cooling devices are possible. So mainly what we've been using in our pilots is that we use this capacitivity to sort of make the demand response possible. And then this sort of, if you can shut down the devices for a long time, then you can actually trade the flexibility in this day ahead and intraday market. And also there are heating which is not in that critical areas, for example in parking areas or like that, which are not that critical and can be used as a sort of demand response for the sort of Nord Pool market, not the TSO reserves. Air conditioning and lighting is sort of not that good source, at least in here, because I mean the air conditioning requirements vary greatly depending on the use of the building. For example, one of our pilots is supermarket, which is the requirements are for air conditioning for that supermarket are sort of based on the amount of people that they have on rush hours. So they basically have a lot of slack. But in this particular case, for example, the AC air conditioning devices were built so that we couldn't actually utilize that overcapacity at all. So what we have found out is that the devil's in details when you go to these buildings is basically you can look that they might have a lot of possibilities for demand response, but you actually have to go to the site to see how it is built, so that you can to be sure that you can actually utilize that potential. Lighting, of course, can have potential, but it has to be very adjustable. So problem is that there's not that much LED technology installed in all buildings yet. So, and also there are sort of interferes with energy efficiency measures that has been taking place in these buildings. So demand response and energy efficiency are not always walking hand to hand, especially in the situation where you need to increase the energy consumption, which will happen when there are too much electricity in the system. Backup generators, which are really good sources for demand response, because you have to sort of test run them from time to time, so that can be also really good source of flexibility, and it's really really handy on the market environment that we have here. So basically what we have found out from the buildings is the best or more versatile building type is sort of storages, and especially freezer storages. Because they have a great capacity. There are a lot of sort of the stuff that is frozen can take a lot of energy into it and then release it. And it's really a flexible asset in market environment as we have here in Nordic. And also if you have sort of series of compressors in these sort of storages, you can use that for frequency control reserve also. So basically what we have found out in our pilot cases in this sort of freezer storages, the shutdowns can be very long, even up to 12 hours. So for example, if we have really a cold spell here and lack of capacity, this sort of 12 hours stops are really worth a lot at the market. We have been running this particular site for a year and a half now, and the monthly savings from electricity price varies between 10 and 25. So they have a lot of seasonality, of course, because I mean, for Honeywell, for example, you don't need to cool the storage that much. You just open the doors basically. The payback for our devices was below 6 months in this particular case, and it's even lower in the similar type of sites that we are working currently. And it's very easy to implement because the controlling algorithm is just on-off. So basically, you don't need too many hours to get this up and running. And we've been running it for almost 2 years now without any technical failures also. So it's this sort of buildings are the savings versus the benefits is really good for those, which we have had an issue with other type of buildings that we've been working with, because usually the savings are so small that the investments and the hours required doesn't really justify the investment. Also in these cases the additional benefits can be gained if you start really optimizing the sites, which is basically currently run those sites against spot price, but you could also run it against intraday market where you get at least as much benefit as we get from the spot market at the moment. And also via better metering of the temperatures, we could probably get more better algorithm in place also. So basically, as a summary and conclusions, the need for demand response is increasing in Nordic market. Basically, we have had quite a lot of flexibility in Nordic because it's a hydro-based system. But at the moment, the increasing amount of renewable energy means that the flexibility available from the hydro won't be enough. And also, we have a lot of shutdowns of thermal production here in Nordic happening at the moment, and the only capacity built except the renewable is basically baseload capacity, which will be running all the time once it starts running somewhere in the near future. Also, the market infrastructure, it's not built for demand side participation at the moment. There isn't, for example, a role for aggregator, as I mentioned before, and some of these sort of network codes are just written for production. So basically, what we have to do at the moment with TSO is to sort of rewrite these rules as we go along, because they really haven't thought that the demand side would need to participate into this equation like it should at the moment. So, and also the benefits of demand response in buildings depends, of course, heavily of the use of the building, because it might have a seasonality in it, and also a daily rhythm really affects how you can use the demand response from that building, at least in sort of if you are selling it to the marketplace. But this sort of storages and resource storages especially are really good because they don't really have, or they are not used sort of as a working hour rhythm. So in that sense, you have the flexibility basically outside also the office hours. And they can be used in many marketplaces, so you can optimize it also a little bit. And the implementation is really easy because there are not too many things that you need to control technically. Like I said before, the savings potential as the electricity price-wise is somewhere 10 to 15, or in this resource storage cases, or even up to 25. So in that sense, for these sort of businesses, it's actually quite good savings, which they won't get otherwise. I mean, energy efficiency saving numbers are something like 1 digit. So in that sense, it's really interesting for the players. The problem is that majority of the buildings buy their energy as a fixed price. So basically, shifting consumption from the daytime to the nighttime doesn't really provide any economical incentive for them. So basically, they need to also change the way they are buying electricity, and that's a little bit bigger decision in many cases than just starting to implement the demand response, which the concept they understand, but in many cases the changes that they need to make how they purchase the electricity currently might be a sort of a larger issue. Okay, that was my bit.
Okay, Jukka-Pekka, thank you very much for your presentation. Last but not least, I would like to pass the microphone to Scott Petersen, Business Development Director for Smart Grid Solutions in Europe and North Africa at Honeywell Building Solutions. Scott will present the experience from the UK when it comes to enrolling commercial customers in demand response programs without financial incentives. Scott, given that Mr. Stamatiu unfortunately could not join us today, it seems that we are ahead of the schedule, so you can take your time. The floor is yours.
Thank you, and good afternoon, everyone. So today I'm going to share some of the learning points that have come from our demand response project with British utility company Scottish and Southern Energy, or SSE as they're now known, and particularly their distribution business. I'll be describing how we've been able to recruit 30 organisations to enrol on a demand response program without having to pay them any financial incentive to participate. A major challenge and a first for any demand response program, certainly in Europe. So, but first, a quick overview of just what the project is. So, in 2010, the British energy regulator Ofgem launched a £500 million 5-year initiative to fund the implementation of innovative smart grid projects, the technologies and commercial models that go with those, with the intent of proving solutions to reduce the £36 billion of upgrade investment that they've forecasted that they'll need by 2020 to make the UK's electricity networks fit for purpose. So SSE's Thames Valley Vision project, it's located in the town of Bracknell, which is in southern England, about 30 miles west of London. And here SSE has got a near constrained network which needs tens of millions of pounds of capital investment and the resulting construction disruption that goes with that to avoid blackouts in the near future when it won't be able to meet the rising demand for electricity that's happening in the Bracknell area. And this is pretty typical of networks across the UK. Now, Honeywell is employing its proven automated demand response, or ADR, solution on the sites of 30 of the largest electricity users, and we're doing that to reduce or shift the afternoon peak load. And you see the profile on the network down in the bottom left of the slide. So the conventionally distribution network operators would as they try to meet their rising peak, simply invest in more capital to meet that peak. And the issue with that is that you're spending all that money just to cope with those few hours in the afternoon. And that's not every day, that's only certain days, and that's only certain days of certain months of the year. So it's a huge amount of investment to address just quite a infrequent problem. Now, if they can do that, they can show what the results are of this project and publish it for all other DNOs across the UK to benefit similarly. So at the heart of the Honeywell ADR solution are buildings, and with SSE, Honeywell performed upfront analysis of the demand profile on the network, and we found that 84 largest commercial buildings, there's one industrial site as well in there, were responsible for nearly 90% of the peak demand, and 30 of these for 62% of that demand. Now, due to the low profile of a number of these, the sites, such as the continuous process at the agrochemical site, and also as one of the large electricity users is actually the council street lighting, there's about 10, and there's similar other ones like that, some 10 megawatts wasn't suitable for addressing with ADR for load reduction. So the ADR solution, just quickly to describe that, involves automatically reducing or turning off electricity to devices in buildings, such as their heating, cooling, lighting, motors, fans, and doing that for short lengths of time without affecting the building performance or the comfort condition for the comfort conditions for the occupants in those buildings when SSE needs to avoid high demand peaks on the network. And of course, there are no carbon emissions as a result. Now, we identified 24 buildings to target for the project, and well, minimum, and can access at least 10% of the building's load. So that provides us a target of 1.4 megawatts for this project. And since 2013, we've connected 15 buildings which are participating in regular demand response events, and we're currently in the process of connecting another 5. So our teams are out there doing that as of today. And we have agreement by 22 organisations with the target of connecting a total of 30 buildings by the middle of this year. Now, if we look at the results from an ADR event, here's the results on this slide for one medium-sized commercial building with a peak demand load of 265 kilowatts. And we started by turning off 10% of the load. And when we turned off 10%, no one noticed. Then 15%, no one noticed. 25%, 36%. We turned off 36% of the electricity in the afternoon for 2 hours, and not a single person in the building noticed. So there's a lot of load reduction potential that can be accessed in buildings, though obviously because people haven't got the experience of using it, there's quite low awareness in commercial buildings. People are reluctant to obviously dive straight into turning a third of the load off. So we'll always start at the lowest levels, and we'll build up from there. You can see down on the right-hand side of that slide what we turned off and turned down to be able to obtain that load shed. Now, for the purposes of the project, it was important to connect a range of different buildings because this is about generating learning outcomes to share with other distribution network operators. So we wanted to obtain the learning from their different experiences. So a broad cross-section participate, including commercial, educational, public, leisure, hospitality, healthcare, and retail buildings are all connected in the project today. And as we'll see a bit later in the presentation, not all organisations jump at the bullet to take part, but we found that the most likely to join were large multinationals rather than just smaller local businesses. Organisations that have a strong community involvement out there, and we'll see why. Also organisations that had participated in demand response before. So we've got organisations here that are American, who have their head offices, UK head offices based here, but their American buildings over in the US are participating in demand response programs, so they have experience of it, they know what it is, so they were happy to participate over here as well. And then also organisations who have high corporate responsibility involvement, and corporate responsibility credentials are very important to them. This project fitted very much with those aspects, and so we leveraged those in the way we targeted organisations. It was also important that their participation experience was good, and that they continued then as a result of that to support the project and keep participating. And so we ensured that demand response events had no negative impact on the running of their buildings. Keep getting that. So this is the only demand response program where organisations have agreed to participate for no financial payment. Why is that? Well, apart from the fact that when SSE started the project, there wasn't a budget to be able to do that, but also part of the project is looking at the financial aspects that are required. So we started at zero, and it was to look to build that model later on. And so we looked at how we could do this without any financial incentives. And the main reason that organisations joined the program was to be a good neighbour. So it was really important to communicate the local role of the project and the benefits to the organisations on a local basis. So these are all organisations connected to the same network, so geographically they're in the same area. In fact, you stand at the window of one building and you look out and you can see all the other participants around through the windows. So there was also the other aspects that went with that was contributing to the energy security in Bracknell. So by their buildings shedding load, they were able to then avoid future blackouts. Constructing bigger primary substations, digging up the roads to put bigger cables in was going to create a lot of disruption, road works, delays to their employees getting to work, all of those aspects that they wanted to avoid. Also, this is a public, transparent project, so Ofgem published the results of this and all the good aspects of those, and so these organisations were allowed to all those good news and all those aspects there to wash across their brands and support those. Participation also was able to be used to strengthen the green credentials of some companies. An example here is Fujitsu, who were involved they're involved in business in the community. That's a very important part of their corporate responsibility program, and actually participating in this project enabled them to move from a gold status up to a platinum status, which they were delighted in. Now, organisations can also publicise their involvement, so they can use that to strengthen their reputation, putting out press releases, putting it on their websites, using it as part of what they're doing and how they're contributing to all the good aspects that this project is providing. And also, broadcast their involvement in a groundbreaking project, a first in Europe project. So very much the soft benefits were the main reason that these companies were participating. So how do we broadcast these benefits and get organisations to realise the value of all those soft benefits? Well, key to all of this was extensive engagement up front in the project and then throughout the project, and it continues today. So an engagement plan was developed right up at the start of the project and involved a mix of different tactics which were used, and they reinforce each other as we go through. So With the local Chamber of Commerce, we set up town hall meetings and invited organisations to come in. They tended to be breakfast meetings to learn about the project, how they could involve and what the benefits would be. We ran specific focus groups to understand what were the key reasons that would make people join, apart from financial. The SSE have set up an advisory centre up in the main shopping mall up here called Your Energy Matters, where the public can go in there and find out all about the project and see demonstrations and sign up for different aspects of it. There's obviously a website where you can find information about the project. We've been involved in local community events in Bracknell and sponsoring of those. We invited the government's energy department to come out for a day, and we did a automated demand response demonstration for them and a question and answer session, which they all came out in the bus to see. We put together case studies of the different buildings that are being involved in this and how they've participated. The press have got involved, and there's been a lot of interest from them, so there's been interviews with those and a lot of articles as a result of it. We've been involved in awards events, so we put this project into public sector awards, won one of those, so with the Bracknell City Council winning that. We do face-to-face meetings with organisations, and we've set up an ADR user group where those organisations can come together on a regular basis and share their experiences. So a whole range of these things, very important to communicate the benefits and experiences and all the positive aspects of participation. And as a result, we've got a range of high-profile organisations that you can see on this slide whose facilities are connected to the Bracknell network, and they've joined the ADR project, and they participate regularly now in demand response events, and we'll be adding about another 10 of those very shortly. You can see the range of different types of organisations there, and obviously recognise some of those brands. So what have we learned as a result of the ADR project so far about recruiting and convincing organisations to participate in demand response events for only those soft benefits? Well, it's important to spend a good deal of time understanding who to target up front. What sort of organisations are going to be the most reliable in wanting to participate, are going to benefit from their participation in those, and some of the points I made in the earlier slide. Then segmenting the large electricity users into those types of organisations with most benefit. Then we needed to get the buy-in of senior person in the organisation. That was quite key. We found it in earlier stages of the project where we had stalled decisions made by them. It's because mainly the facilities people, they're more focused on the perceived risks to their precious equipment of making that participate. But if you get a senior person in the organisation who buys into those soft benefits and the corporate responsibility aspects and the whole local responsibility part, then we get them to agree to participate much more successfully. SSE funds the installation of the equipment, which only involves a site audit and installation of a simple gateway device, which is about half the size of a laptop. It takes about half a day to install. So there's no disruption on site, but it was important that that we weren't having to go through the organisation's internal investment approval process, which, if it wasn't approved, apart from delaying the whole process, if it wasn't approved, it could mean that they didn't participate. Also, getting some buildings on early and running events with them and proving that load can be reduced without impacting the building helped convince others who were a bit sceptical. So those early adopters were very, very important. And getting the big brands on board to join also helped convince others, especially other big brands in there. So you've got Dell that's agreed to participate. So 3M sees that, things. If they're a large organization doing that, then we should be doing it as well. And then through the engagement and communication activities, we continually shared this with potential recruit organizations, and that was very important to get them to join. And this included informing them about the future issues that Ofgem was looking to solve, and then how they were contributing to that and contributing to helping that. And of course, we ran load reduction events that made no impact to the building performance. So we were ensuring that there was no negative experiences, and it was all very positive. So, in summary, you can, and we have, convinced organisations to participate in demand response programs without resorting to financial incentives, and by focusing on their social responsibilities in the local area where a lot of their staff live, and actually a lot of the people in these organisations live and travel to work. And I can't help but reiterate how important the upfront and ongoing engagement has been. And SSE, I mean, they've been exceptional at this, doing this, with Honeywell helping them through that process. Getting participants together to discuss and share their experiences is also a great way to maintain support going forward. But on a final note, despite this success, SSE recognises that other demand response programs are being developed, and they offer financial payments, and these organisations that are involved here are going to have those offered to them, and they're going to be able to participate in those. So SSE will need to compete with those, and will in the future probably need to pay to keep them participating. However, I hope you found the presentation enlightening, and I thank you for your interest today.
All right, thank you very much for your presentation, Scott. It was very interesting indeed. And now, with no delay, I'd like to open the floor for questions. We have received a question from Willem Strabbing. Sorry if I'm not pronouncing correctly the names. The question is, are national governments willing to change the market infrastructure in order to benefit fully from demand response in buildings? I'm repeating the question. Are national governments willing to change the market infrastructure in order to benefit fully from demand response in buildings? I don't know who would like to answer this. Perhaps Bertrand, who is, has a picture about the French government, perhaps.
I mean, you're asking me like a $100 question. No, I don't have really. I mean, I have a view about the French market. I mean, what I could say is that the building regulation in most of the countries tend to focus very much on the envelope of the building, meaning that, you know, like it's aimed first to renovate, to retrofit the thermal performance of a building. But I think it is changing, and the recent directive on energy efficiency is asking member states to come with a straightforward plan for demand response deployments, and that should include buildings. So I think, as it is a very new topic, demand response in building, it's something which is not really addressed yet in regulation. There are some projects under development, funding project, but it's not being translated in regulation yet. But it's coming. So so this is my response, or at least what I know from what is going on in Europe.
All right,
but then just maybe to
I don't know if there's anybody.
No, just maybe to complement. I mean, yeah, okay, great. I mean, you have some regulation about the BACs, you know, like the building automation and control system in buildings. And for example, you know, like the European directive, the Energy Performance in Building Directive is asking for is giving incentive to member states to deploy such product and system. And in many buildings, as Scott has shown, that is a kind of prerequisite to implement the demand response program. But that's obviously not enough, and you need to really, I think, have a much deeper discussion at national level, I would say, and that has not happened yet, but surely it will happen at some point.
All right. I don't know if anyone else wants to add something. Just unmute and then mute again, and you can have your say. Otherwise,
okay, I can say something from Finnish point of view. I mean, when we started in 2011, the attitude from TSO was that they didn't really believe that the DR would sort of be useful resource for them. But actually, from starting this year, they are financing a lot of these demand response pilots from their own funds, because they have now realized that they are going to face large troubles with the existing new build capacity that will be here in Finland, because I mean nuclear and wind is not very good combinations for them. So they have understood that they will be facing trouble system-wise. So the attitudes in 2 years has changed quite a lot. There are of course still a long way to go, but at least now we are going ahead. So I'm really positive at the moment, which I wasn't 2 years ago.
Mm-hmm. Thank you, Jukka-Pekka. Anyone else would like to add here?
I can give a perspective from the UK, definitely. For the involvement of buildings in demand response programs, there are a lot of developments going ahead in the UK. Ofgem, the energy regulator, is very keen for them to participate, especially in load reduction, mainly because there are no carbon emissions involved, so it's a very green solution. Also, there's a lot of buildings out there, so it's a huge untapped resource that's available. And if you look at the US experience, where many tens of gigawatts that are accessed over there, that potential exists over here as well, rather than having to build more spinning reserve fossil fuel powered power stations to overcome our supply demand balancing issues going forward. So there's a lot of interest. You've got the TSO National Grid, who is setting up programs within their existing short-term operating reserve demand response program to attract buildings to participate in those. They haven't beforehand because of the variable baseline aspects of that, but they're overcoming. We've worked with them to overcome those, and they're introducing those. They're bringing in new services. There's the new demand-side balancing reserve service that will be launched in summer this year, which specifically looks at an emergency backup to industrial and commercial buildings to be able to turn down load when asked as an emergency backup. So very much so, buildings are getting involved, and there's lots of opportunities for those to get involved in demand response programs. And I see that continuing across Europe. I mean, the opportunity obviously exists there. It just needs the regulators to be able to, and governments to understand that and be able to modify their regulations to accommodate demand response in the demand response programs.
All right. Thank you very much, Scott. See here we have one more question from Hassan Ridwan to Scott. The question is, can you give us a bit more details about how you saved 97 kilowatt and no one noticed the effects? What are the equipments that were turned off?
Sure. So it was between 4 and 6 o'clock midweek. So in the building, what we do is when we do a shedding strategy design, we look at how the building's used, how by the occupants in there, what they're using all their different electrical devices for. So in the bottom floor of the building, there's a whole suite of meeting rooms, and after a certain amount of time, those meeting rooms aren't used any longer. So we're able to turn off the HVAC systems to those. There's a large restaurant which closes at 2:30, and while it generally is all still running, we're able to turn that off and turn off vending machines and whatever to those. But through the rest of the building, we're turning down the heating or the cooling. It was the cooling for that specific event. So turning down air handling units, turning off one of the chillers. We didn't have to turn off any of the lighting for that one there. So that's another opportunity in there. So that's what we that's how we got to the 36%. And because we did it in a way where where people were working, we weren't doing anything that impacted them, and we were turning the temperatures down just a small amount, and people don't really notice it until there's quite a number of degrees change. And over the 2 hours, that didn't happen. The thermal inertia of the building was unable to keep that keep the temperature so that people didn't notice. Okay.
All right, thank you very much. Willem Strabing is asking, what were the financial benefits and the total energy savings in the UK project?
So it wasn't specifically around energy savings. So what we're saying is we're not saving electricity. I mean, we are, in some circumstances we are, but actually what we're saying is we're shifting that peak. So we're moving it from one period to another. So for example, if we turn the air conditioning down between 4 and 6 o'clock, when we turn it back on at 6 o'clock, it recovers, and so there's an increased use of electricity to get it back down to temperature. So we're basically moving electricity from one period to another. Now some of those buildings actually there have run demand response events using the ADR equipment on their own buildings. So have turned stuff down and see what impact it has in different parts of the buildings, and then found that they didn't need to have it at such a high setting and didn't need to have fans running full time here and there. So they've actually been able to turn stuff down as a result of it, and they have made electricity savings. But that hasn't been a key objective of the project. It's about moving the peak and reducing the demand on the primary substation so that we can don't need to upgrade that substation to a larger one.
Mm-hmm. Scott, I think the question is targeting more the financial benefits, and that's the sense of savings in this question.
Yeah. Well, the financial benefits for the distribution network operator for SSE. So rather than having to spend tens of millions of pounds on an upgrade, they don't need to do that. So it's looking at what the value of avoided or deferred reinforcement capital is. So, you know, it's taking into account the interest rates of that capital that they can invest in other things that they don't have to do it on this. And so that's how we work out what the value of it to them is. As a result, the payback is in months for this project.
Okay, thank you very much. Now we have a question for Bertrand and Scott. The question is, can you say something on the capacity in total that you were able to switch? This question is coming from Diederik Apotheker. Sorry again for the pronunciation.
Well, for Honeywell's project, we're looking to turn off 1.4 megawatts from the buildings that we've got connected, which will actually exceed that, because that's just based around the 10% reduction, and there's a good chance we're already doing 1.4 megawatts just from the 15 buildings, and we're going to get 30 buildings on there. Saying that, the remaining buildings to connect will be smaller buildings because we have the larger ones connected now, but we're going to get easily up around 2 megawatts. Now we're if we were able to just select large buildings from anywhere in the country, we get a lot more than that. We are geographically confined to those buildings connected to that specific network. So we start at the bigger users on that, and then move down to smaller users. So we're trying to get the largest 30 users on the network. There's a number of those that can't participate for the reasons I said in the presentation, but we're getting most of those connected. So we're getting enough to be able to prove that ADR can be used as a valid solution going forward to avoid unnecessary reinforcement capital investment, which is the whole objective of the project.
Yeah, I mean, I'm afraid we just start to have the first results of the project, and the only figure I have is for one building, one tertiary building, and actually for 1 day, and basically we managed to switch 500 kilowatts of cooling from day to night. So it's the only figure we have, but that I think show that it can be quite substantial. But we should I think this project is running for, I mean, the EC grid project is running for 2 or 3 years only, so we should have more and more results. But it's quite substantial, I would say.
Okay, thank you very much. Next question is coming from Aaron Bredenbagen from Enernoc. What are the largest barriers to participation? I don't know who would like to provide the first answer here. Perhaps Jukka-Pekka.
Oh.
I would repeat the question. Okay.
Participation from, the participation, I guess, is sort of, from our point of view, the biggest challenge is sales challenge at the moment. So, because I mean, setting up the automated demand response requires some change of sort of traditional ways of doing things, and also if we move into the heavy industry where they basically are, which is based on some process, they don't like to mess with the process that much. So you have to sort of prove that there won't be any harm for the production process. In buildings, I guess, at least from our point of view, because we are selling the, or we are sort of trading the demand response at the market. So the things that we have to do, the things that we do have to be sort of measured properly, and also they have to work when he push the button. So in that sense, that's a sort of a big hurdle in buildings to get that sort of demand response measure done in that sense. And also because I mean we don't have that large building complex as, for example, in this UK case. The size of the flexibility from the buildings is so small that it's not very suitable for the market environment. So in order to aggregate this, we need to be a market participant, and for startup currently it's a really costly business. So I would say those are the main hurdles, at least from our point of view.
So from a Honeywell perspective, the main barriers, the hurdles, are the perceived risks that the organizations we reach out to have about their participation, because they don't really know about demand response. There's not a lot of experience in Europe, and so that whole lack of awareness makes them all a bit worried about if you're going to turn things down and off in their buildings, what's the impact it's going to have on the equipment, and what's it, you know, their staff are going to complain, they're going to get too hot, too cold, all those aspects. So we you know, a big part of what we tell them at the phone is that we ensure that there is no impact on that. We always start at the lowest level of load shed, and then we can build that up over time. So part of that is that, you know, if we go in at the facility manager level, then because of those risks, they won't participate. It's just not worth it. And so it was that's why we ensured that we went at a higher decision maker level to be able to do that. And then the second barrier which is a common one across the UK, is the level of controls inside some buildings. Now we don't have to have controls to be able to do it. We can fit simple PLCs if they don't have any controls. But I mean, if you go into a building and it has a building management system that can access as many electrical devices in the building as possible, that's what we call a demand response ready building. And the 3M campus was an example of that, where we'll be able to, for a very simple installation, just put the gateway on, connect it to the BMS, we can access 600 kilowatts to a megawatt from that facility, because it reaches out to be able to just every single electrical load device is on that system. So that's the ideal. And other buildings, smaller buildings, where you might want to put some controls in to access it, you had to look at how much load was available versus the investment you were going to make to add extra controls. Sometimes it wasn't warranted. So not all the time. So those are the key barriers that we found from the project.
Thank you very much, Scott. Next question is for you again, Scott, coming from Anastasios Titsanis. The question is, have you experimented with lightning loads, especially dimmable? If yes, how did you assess occupants' visual comfort, flexibility?
Yeah, we haven't dimmed lighting. What we would do for lighting, we just turn that off in various parts of the buildings that aren't being used or are near, because it's only for, it can be just for an hour, near a lot of windows, what have you, and that depends on how your lighting is segregated in the controls. But most of the time it's been in parts of the building that aren't being used at certain times, or after certain times we can turn the lighting off there. So we're not going down to that level, because you've got to look at you want to minimize the investment to get the maximum load. So you take a Pareto approach at a building, really, and you look at 80% of the electricity is 20% of the load devices. So you go and address those 20% of those load devices, and we make sure that our engineers, I mean, if we let them go, they do a PhD on a building of what you could turn off, where, everything right down to individual plug loads. But you've got to look at the investments that's required. So we very much focus on the key main electrical plant and focus on getting as much load reduction as we can from that. Tends to be the HVAC systems, AHUs, fan core units are key in most commercial buildings.
Thank you, Scott. We have one more question from Aaron. The question is related to the previous question he asked about the main barriers, and this time he asks, what do you suggest? What are your suggestions to address those barriers?
Well, for the barriers that I said, so those perceived risks, a great example was with Waitrose that we went into, part of the big John Lewis group. Went and saw their facilities director, and he was there with his team of facilities managers, and they've got a responsibility for the comfort conditions of all the employees on all the sites, the refrigerated warehouses, and the quality of the goods, and if something happened to them, they're worth millions of pounds, maybe. So looking at the risk aspects of that, whereas the sustainability director, she very much was looking at the corporate responsibility aspects, the reputation, the green elements, and she saw this project as very much contributing to that. And also that we had a dozen other big organisations out there who were participating without any issues and problems, and we had the Honeywell brand, so some trust around that the technology actually works, and we're using it all around the world very successfully. So going up at that level and making sure that our value propositions tailored very much around the hot buttons that they've got was key to overcoming the hurdle of perceived risks. On the controls side, like I said before, we'll look at minimising the the investment. Our system can talk to any BMS system, any SCADA system out there without any integration costs. So that's one way of minimizing that. And we don't have to have a BMS system in a building. We can put in a simple PLC to access it. So that's how, you know, the technology design aspects of it, just to make it very, very simple and easy to connect up buildings at the lowest, at the most cost-effective point is very important too. Hope that answers your question.
Okay, thank you very much, Scott.
I can say from the Scandinavian point of view, tax cuts always helps. So I would like to see some tax cuts for the buildings who are participating on DR programs from the government side. So.
Okay. And Bertrand, would you like to add something in this question, or any final comments?
No, I think it's just maybe to summarize from my perspective, it's really like to bring tangible benefits to the participants of such scheme. I mean, because it involves so many people, so many technologies in many projects that it's difficult for people to see what the value added of the aggregation. So I think it's bringing economic benefits and explaining to all the participants that's what the program has brought. So I think that it's a key component. And for instance, you know, it means sometimes to change the rules, the regulatory rules, and for example, you know, like to allow like the auto production of renewable energy in some countries. And in a nutshell, it's really, I think, for policymakers, for business, and also for people who are involved, really to build a common roadmap and really to bring together this pilot project and to draw simple conclusions, which really should look at the benefits and how to share the benefits with everyone.
All right, thank you very much, Bertrand. I don't know if you have any final comments. Okay, I think this was the last question to the panel. I'd like to thank you all very much for your participation. I'd like to thank especially the speakers for their very interesting presentations. For those who ask about if the webinar has been recorded and the presentations are available, yes. The webinar has been recorded and will be available for you to access it on the SEDC website along with the presentations. So you can visit our website and have a look to the presentations and this interesting discussion and listen to this interesting discussion. Hope to see you again on our next webinar. We'll definitely keep you updated, and thanks again. Goodbye.